Welcome to today's lecture on psychrometry. Okay, so this will be actually a lecture series on air conditioning. But before understanding any chapter in air conditioning, you have to gain a thorough and firm concept on psychrometry. Okay, so what is psychrometry? It is study of moist air. Why we are dealing with only moist air? Because in practical, air does not contains only dry air. We know the components of dry air, different gases. Nitrogen is present in the most quantity, oxygen, carbon dioxide, different gases. But it is never in dry condition. It always contains some amount of moisture. That's why we are dealing with moist air. Psychrometry itself is a study of moist air. Okay. Now we will learn these topics: DBT, dry bulb temperature; WBT, wet bulb temperature; dew point temperature; specific humidity; relative humidity, RH, or denoted with phi. It is very important. This topic is very important, relative humidity. Degree of saturation. Once you understand these topics in psychrometry, it will look very easy and interesting to you. Okay. So I'm starting in a fresh page with the first topic, that is DBT, or dry bulb temperature. Okay, it is nothing but the ambient temperature or the atmospheric temperature. Suppose you have got a thermometer. This is the mercury level and these are your readings. Suppose this mercury level reaches 30 degrees Celsius. What is the meaning of this? This meaning is that the temperature of the moist air is 30 degrees Celsius. When we say that today's temperature is 30 degrees Celsius or 35 degrees Celsius, we are talking about the DBT, or dry bulb temperature. Why it is known as dry bulb temperature, DB? Because the bulb of this thermometer is dry. It is dry, absolutely dry. When air passes through this bulb, it senses the temperature and the mercury level goes up and it records here 30 degrees Celsius. In this case, that is DBT, that the ambient temperature or the room temperature which we talk about. But this was very easy to understand, but you have to understand wet bulb temperature, WBT. What is WBT? Suppose you have got a thermometer and you have wrapped moist cotton here. You have wrapped moist cotton. Suppose this is the level of the thermometer mercury and these are your readings. We want to record the wet bulb temperature. Then I will tell you that what is the real meaning of this. Suppose air is passing through this bulb. Now you can easily understand why it is named wet bulb, because it is wrapped with moist cotton. That means the bulb of the thermometer here is wet. Okay. When air is passing through this wet bulb, what is happening? Let's see. Air is at a higher temperature than this moisture. So moisture will take up the heat from this air. The moisture is going to take the heat from this air, isn't it? This moisture is going to take the heat from this air. Or you can say that air is going to absorb the moisture. That means whatever be the case, the thing is that air is cooling down. Air is cooling down. This is same as the phenomenon that when you take bath you feel cool and pleasant, because the moisture absorbs the heat of your body. Water absorbs the heat of your body. Similar is the case. Moisture is absorbing the heat from air. Now air is cooling down and now the temperature recorded in the thermometer is suppose 25 degrees Celsius. This is known as WBT. WBT is 25 degrees Celsius in this example. Okay, now what is its significance? That is very important. What is the significance of WBT? By seeing the wet bulb temperature, you can easily get an idea of today's relative humidity. Yes, I have not explained to you relative humidity yet, but see, half of the idea about relative humidity you will get once you understand WBT. Now, one question that might come to you, that why air is absorbing the moisture? Answer is very simple, because air has the capacity to absorb the moisture. Now, what is humidity? It is the amount of moisture present in the air. If relative humidity is 100%, suppose, if today's relative humidity is 100%, please understand this carefully. If today's relative humidity is 100%, then air is not going to absorb any moisture. Then what will happen? Air does not absorbs any moisture. Air does not absorbs any moisture. From where? From this wet cotton. If air is not absorbing any moisture, because how will it absorb? Relative humidity 100%, air is already filled with moisture. How will it absorb any further moisture? So it is simply saying no, that I cannot absorb it. Now, if it cannot absorb any moisture, then will it cool down? It will not cool. It will not even cool down. It will not even cool down. So, now the thermometer, that is your wet bulb thermometer, where you have wrapped the moisture, wrapped the cotton, wet cotton, is of no use, because air has not taken any moisture from this wet cotton. And the reading of the thermometer will be simply 30 degrees Celsius, or the original temperature of the air. Isn't it? Because air has not cooled down. So the thermometer will show whatever is the original temperature of the air, that is 30 degrees Celsius, that is equals to dBT. So here dBT is equals to WBT. So we have understood that when relative humidity is equals to 100%, when relative humidity is 100%, it implies that dBT is equals to WBT. I think I have been able to explain it to you. Okay. Now, suppose relative humidity is very low. Suppose if today's relative humidity is very low, what will happen? This is my thermometer. I have wrapped wet cotton. And air is passing through this. When air is passing through this, relative humidity is very low, I have told you. That means air already contains very less amount of moisture. So when air passes through this, air will tell happily that yes, give me more moisture, I can accept it. When air is absorbing more moisture, its temperature goes down, because it is cooling down by absorbing moisture. Now, suppose today's dBT was 30 degrees Celsius, same as previous example. Now, the WBT will be very less. WBT will be, suppose 15 degrees Celsius, because air has cooled down severely, because it has absorbed lot of moisture from this wet cotton. It has absorbed lot of moisture. Why? Because its relative humidity was very low. So, when relative humidity is very low, your WBT is going to be very low. Okay. So what is the difference between dBT and WBT? dBT minus WBT is 30 minus 15. This is for this example, mind it, 15 degrees Celsius. This is also known as the difference between dBT and WBT is also known as wet bulb depression. So when WBT is very less, wet bulb depression will be high. When that means when relative humidity is also very low. But when relative humidity is high, wet bulb temperature will be high and wet bulb depression will be low. When I told you about relative humidity 100%, that means what? Wet bulb temperature will be equals to dBT, and I have also explained to you why. Because air cannot absorb any moisture, and if dBT is equals to WBT, then what is your wet bulb depression? Wet bulb depression, dBT minus WBT, it is going to be 0. Okay, it is going to be 0. So I am giving just bit summary. What we have understood is that if WBT decreases, that means, okay, if relative humidity decreases, if relative humidity is low, then WBT is low, and wet bulb depression, that is the difference between dBT and WBT, will be high. Wet bulb depression will be high, and reverse is the case when relative humidity is high. When relative humidity is high, then WBT is also high and depression or the wet bulb depression is low. Okay, this concept is very clear to you, I think. Now we are going to learn about specific humidity. Okay. Okay, so what is specific humidity? Specific humidity is also known as absolute humidity or humidity ratio. It is also known as humidity ratio or absolute humidity. Okay, suppose this is a volume of moisture. This is a sample volume of moisture. We cannot perform our analysis in total atmospheric air. We have to take a small sample of it. So that sample is. Now, I have told you that air is not never found in totally dry. It is a mixture of dry air and moisture. So, it is known as moisture. Now, suppose the mass of dry air present is Ma and mass of water vapor is Mv. That means in certain volume of air, Ma is the mass of the dry air present and Mv is the mass of the water vapor present. Now what is specific humidity? I have told you it is denoted by this W sign. It is nothing but mass of water vapor upon mass of dry air. This is your specific humidity. That is mass of water vapor present in the it is nothing but the mass of water vapor present in the dry air. See, this is the mass of dry air, this is the mass of water vapor present. When mass of dry air is equals to the mass of water vapor, I will say that specific humidity is 1. Okay. Now you have to understand there is now specific humidity is a function of PV, that is vapor pressure. It is the function of P small p is partial vapor pressure. It is a function of partial vapor pressure. How this we are getting? I am showing you. It is a small derivation. You have done it before, I think. Suppose W I can write as mv by ma. Okay, and we know that capital V volume, this total volume divided by mass of air is equals to specific volume of air. Okay, so and capital V by mass of vapor is equals to specific volume of vapor. Okay, specific volume of vapor. So I can write mv as, what is my mv? Mv would be capital V by vv, and what will be my ma? It is capital V by va. So I will get this as va divided by vv. This is nothing but mv by ma. This is nothing but w. This is clear. This is clear. Now we know that PA into VA is equals to R by MA into T. We know this. Where we are, from where do we get this formula I am showing you? See, we know that P into capital V, PV equals to nRT. If I take N as 1, then what I am getting? PV equals to RT. This capital V, if I just divide it with mass, I am getting this thing. Now what is this? Capital V by small m. It is nothing but, if I take it, suppose capital M, that is the mass, molar mass. That's why I am taking it as capital M. This you have read, understand in chemistry also. So capital V by capital M is nothing but specific. PV is equals to RT by M. So for air I will write this, and for vapor I will write this. This is small v equals to R by mvt. Okay. So if I just put the value of VA, so if I just put W equals to value of VA, we know that W equals VA by VV. If I put the value of VA from here to here, I will get what? MV by MV into PV divided by MA into PA. Once you substitute the value of VA from this equation to this equation and VV from this equation to here, okay, you will get this. This is very easy. What is MV? It is the molar mass of vapor. Whose vapor? Water vapor. Now we know the molar mass, it is H2O. So hydrogen 2, oxygen 16, it is 18. But we take the more accurate value, it is 18.016 PV. And air, for air we have a standard value, that is 28.966 PA. Okay. Once you simplify this, you will get 0.622 PV by PA. 0.622 PV by PA. Okay. PV is what? It is the partial pressure, vapor pressure. It is the partial pressure of the water vapor, and this is the partial pressure of the air. Okay. This is equals to W. This is equals to W. So we have derived that W equals to 0.622 PV by PA, and we know that PV plus PA is nothing but P. The total pressure is equals to the total pressure. This P is the total atmospheric pressure. Total atmospheric pressure is due to both air and both water vapor. This is very simple to understand. Don't make it complicated. Suppose you have got air plus vapor. Total pressure will be what? The pressure exerted by vapor and the pressure exerted by air. Okay. So you will get your W as 0.622 PV by PA. I can write as P minus PV. Now this is constant. Atmospheric pressure in a given region is constant. So I can write that W is just a function of PV. in a given region, this P, that means the atmospheric pressure, is constant, because it will change only if you go up or if you go down. But if you are in a particular locality, it is not going to change. What is going to change is the vapor pressure, that is the vapor pressure of water. Why it will change? Due to the change in concentration of water or moisture in the air. If concentration of moisture in the air is more, this PV is more and specific humidity will be more. If it is less, see, it is very easy to understand. If the amount of moisture present in the air is less, then the pressure exerted by that moisture will be less and specific humidity is also less. Very simple to understand this equation. Okay. Okay, now we will study about degree of saturation. What is degree of saturation? This is very interesting, and once you understand degree of saturation, your concepts will become even more clear. Try to understand that suppose you have got a temperature T. You are in a zone of temperature T. That is, suppose dBT is T degree Celsius. Okay, this temperature is in degree Celsius and S is entropy. You have got this curve in the TS diagram. This I am not going to explain that how you have got this curve, because this you already know. So this, as I am moving in this direction, temperature is constant. As I am coming in this direction, pressure is constant. This is PV, constant pressure. This is PS, constant pressure. What is PV? What is PS? What is its significance? I am going to tell you. Okay. See, suppose you are here. This region is what? Superheated region. First, the moisture. So first remember this point. The moisture that is present in the ambient or in the atmosphere, it is in the superheated form. It is in the superheated form. Suppose at 30 degrees Celsius, this T degree Celsius is 30 degrees Celsius. At 30 degrees Celsius, there is moisture present in the air. There is moisture present in the air in the superheated form, and it is unsaturated, and the air is unsaturated. So this point, this is point 1 suppose. Please try to understand slowly. This is point 1. Here the air is superheated water vapor in unsaturated air. Try to understand. This is superheated water vapor in unsaturated air. Why this is superheated? I have told you that the moisture that is present in the air, it is in superheated form. The water vapor that is present in the air, it is in superheated form. Okay. And the air is unsaturated. Why unsaturated? Because it can hold more amount of moisture. Because I know that the saturation line is this line and I am here. So I can hold much more moisture until and unless I am reaching here. Okay. Suppose at 30 degrees Celsius, my temperature is 30 degrees Celsius. This is just an example. 30 degrees Celsius is a 30 degrees Celsius. I am here. Now I am trying to cool. And my pressure is PV. What is the meaning of partial pressure? Try to understand this point first. Suppose there is moisture in the air, that means water vapor, and the mass is mv. This moisture is going to give some pressure. It is always going to give some pressure. It is very simple to understand. And if I add more moisture, pressure is going to increase or decrease? Increase, because more amount of mass, more is the pressure. Very simple to understand. So when I am here, my pressure is, partial pressure is PV. That means the partial pressure of water vapor is PV at this state point 1. Now suppose I am cooling. Cooling means what? Temperature is, suppose, okay, I'm not cooling. Okay, so suppose this is state point 1 and I'm not going to cool. Okay, just listen. This is 30 degrees Celsius. What I am doing is that I am adding more moisture. I am not going to cool. Okay, cooling I will show you in the next topic. Here this is state point 1 and at the same temperature I am going to add more moisture. I am writing here. At the same temperature, we will add more moisture or water vapor to the air. So I have told you that more moisture I am going to add means pressure will increase, but temperature is same. Okay, see here, try to understand. I am at state point 1. I am adding more moisture. As I am adding more moisture, my pressure is increasing. At first my pressure was in this line, next in this line, next in this line, next in this line, but my temperature is constant because this is TS diagram, so temperature is constant but pressure is increasing. When I am at this point, air is saying to me that you cannot add any more moisture. Air is saying to me that you cannot add any more moisture because at 30 degrees Celsius I cannot hold any more moisture. This is my limit. This is my capacity. This is my degree of saturation. Okay, this is the point where I am saturated. You cannot add more moisture. You are adding moisture here, it's good. You are adding moisture here, it's good. You are adding moisture here, it's good. Air is taking that moisture because it was unsaturated here, I have written. But when you are reaching this point after going on addition in moisture, partial pressure is becoming PS. That means saturated. Partial pressure of the water vapor at the saturated state. It is maximum and air is saying that I have reached this line. That means I have reached the maximum value, maximum amount of water vapor that I can hold. If you add more amount of water vapor, what will happen? Condensation will take place. That means phase change will take place. Condensation will take place. That means at 30 degrees Celsius, I cannot hold any more moisture. This was my degree of saturation. I cannot hold any more moisture. If you add more moisture at 30 degrees Celsius, then condensation will take place. Then the water vapor will come down in form of water droplets, either in the form of dew. Okay, maybe in the form of dew. Okay, this concept is clear. So what I have told is that I was at state point 1. This is unsaturated zone. At the same temperature, 30 degrees Celsius for example, I am going on adding moisture. Air is taking that moisture easily because it was unsaturated. Its humidity was very less. So it was going on taking the moisture and its pressure was increasing and when it has reached this point, air is saying that I cannot absorb any more moisture because I have reached my maximum value. So we have learnt from this that at a particular temperature, air can hold a particular amount of water vapor. Okay, if you add more water vapor, that will precipitate down. Okay, so we have derived this expression that W is nothing but 0.622 PV by P minus PV. So when it is saturated, this point, when it is this equation which I have written is for this point. When the partial pressure of water vapor is PV, when it is saturated, the partial pressure of water vapor is now PS divided by P minus PS. This is constant at a given locality. This is constant. PV has become PS. That is the maximum pressure. That is the saturated pressure. Okay. and W, that is specific humidity, this is omega Ws. This will also be the maximum possible specific humidity. This is the maximum possible specific humidity, because what is omega? It is mv by ma, the maximum amount of water vapor. When the amount of water vapor is maximum, that is air is saturated at this zone, then omega will be maximum, that is omega s. So you have understood this, and you, in any problem you can use these expressions to solve the problem. Okay, so you have understood degree of saturation. Now only one thing is left, that is dew point temperature. Very important, and now you will easily understand dew point temperature because you have understood degree of saturation. Now we are going to discuss a very interesting thing, that is dew point temperature, or how dew formation. Here you will understand how dew formation takes place. Okay, so suppose this is at state point 1, superheated state of water vapor in unsaturated air. Air is unsaturated, because if it would have been saturated, it would have been here. That means maximum amount of moisture. As I am cooling it down, what happens? See, suppose this is state point 1, here the air is unsaturated. That means it can hold more amount of moisture. But it is now at temperature T degree Celsius. Suppose this T degree Celsius is nothing but 30 degree Celsius. So for example, you will say that 30 is my favorite value. I am taking always 30. See, here this is state point 1. Temperature was 30 degrees Celsius. And there was some moisture in the moist air. At 30 degrees Celsius, air can take more moisture. Up to this point, if I come down in the same temperature line, up to this point. So this here, I can add more moisture. But suppose instead of adding more moisture, like we have seen in the degree of saturation, what happens if I just goes on decreasing the temperature? If I just decrease the temperature here, suppose this is 29 degrees Celsius, this point, 27 degrees Celsius, this point. Suppose and my moisture content is same. If I decrease the temperature, still now moisture content is absolutely same. Air has not lost any moisture, neither it has gained any moisture. I am just reducing its temperature. Just think, just try to keep in mind what I am telling. Then you start analyzing in your mind in your own way. But first listen to what I am telling. Here temperature is T1, 30 degrees Celsius. I am just cooling it down. Moisture is same. Nowhere moisture is lost. Now if I reached up to this point, suppose saturated point, suppose this temperature is 24 degrees Celsius or T1. So T1 is nothing but 24 degrees Celsius, for example. Then what will I see? If just I decrease the temperature more, condensation will take place. Air will say at that time that when I was at 30 degrees Celsius, I was having this amount of moisture. It was okay. You could have increased my temperature to this. You could have added more moisture to me up to this point. But what you are doing is that you are decreasing my temperature. Air is saying, you are decreasing my temperature. It's still okay. But when you are taking me at this point, at this 24 degrees Celsius, I cannot hold that moisture which I was having in 30 degrees Celsius. Because I have told you one very interesting thing, that air can hold a particular amount of moisture at a particular temperature. So at 30 degrees Celsius, it was having mv amount of moisture. It cannot have the same amount of moisture at 24 degrees Celsius because it is reaching the saturation line. Okay, so what will happen? You are going on decreasing, but you are not bothering about air. You are going on decreasing. It will happen? Temperature will not decrease anymore because condensation will happen and the moisture will fall. This is moisture. Moisture will precipitate, means moisture will precipitate. This is moisture coming down in form of dew, okay. So this point is nothing but the dew point temperature. In this case, this is your dew point temperature. Dew point temperature at this pressure PV. At this pressure, suppose this is PV1, some different pressure, dew point temperature will be this. At this point, dew point temperature will be this. So dew point temperature is that saturation temperature. Okay, you have understood dew point temperature and you have understood that how dew is forming. You can understand dew. You often hear the term dew when in commentary of cricket matches, because dew is a very important factor there. What happens is that suppose air is having some amount of moisture and the afternoon temperature is 35 degrees Celsius, but 35 degrees Celsius. But as the evening progresses and night approaches, the temperature goes to 23 degrees Celsius, and this may be the dew point temperature. Air was having some moisture and this may be the dew point temperature, and air will say that I cannot have that much of moisture at 23 degrees Celsius, and dew formation will start. Okay. And if dew formation starts, the ground will be filled with dews and bowling will be very difficult. So teams are nowadays very concerned about dew formation, and they don't and if there is a chance of dew formation at night, then they don't go for second bowling option. They will not prefer bowling at night time because the ball will not grip. So you can relate this to your cricket field also, but you need to understand first. Once you understand, you can relate this and apply these concepts in different fields. So you have understood the formation of dew also. Okay, in my next video I am going to explain you about different psychrometric different air conditioning processes. That is also very interesting, and that will be finished in some 15 minutes because you have understood this. You have used your 40 minutes in understanding this, and the rest of your life in air conditioning will be very easy. I am guaranteeing you. And whatever doubt you have, you just ask in comments. I will try to rectify. I will try to help you out. Okay.